what we're going to look at today, again, is looking at the next few subchapters, finding the areas of triangles. If you've got any questions, please call out along the way, because it really will help you. I'm going to go through this pretty quickly. A lot of it is more prior knowledge. So really what we're trying to do is we're looking at how we solve area for right angle, non-right angle triangles. There's a few ways you can do it. The first one is if you give them the base and the height, it's just half of that. Why is it half of that? Is probably a key, one of the key things to know, not so much a massive key one. But if you take the area, if you just go its base times its height, and why the height is always perpendicular to it is if you times these two measurements together, if you take the base and you multiply by the height, it's going to give you an area of a rectangle. Then why is it half of it? It's half of it because you can see that, well, this only takes up half of this part and this only takes up half of that. So base times height times it by a half. Now, always your base and your height, they need to be perpendicular to each other. So it could be, this could be your base and that could be your height, right? But your height needs to be perpendicular to it. So this would need to be at right angles. Alternatively, this could be my base and that could be my height, but that would need to be at right angles as well. So area equals half base times height. Have that in your reference book. Please make sure you know what that one is. So this is base and height. I am sure of it because it's perpendicular. 12 times 20 times a half. So 12 times 6 would give you 120. Included angle formula. How does this work? When two side lengths and their included angle in between the two known sides are known. So what do we mean by that? We've got these two. I don't know why they've got this here. How does this work? So really what you're doing is if you've got this length times this length, right? What you're really trying to do here and how this works, you don't really need to know why it works, but I'll just show you anyway. You just really need to know the formula. So if you're given two lengths and the included angle, so two lengths and the included angle, you can use that formula. Why this works is due to the fact that what we really want to do is we want to actually just figure out the height of this, right? Like what we're trying to do is figure out the height of this. So as we can see, the formula will be, I'm just going to copy this one as well. Sorry, I should have done that. Let me just do this again. All right, that's okay. So what we're actually doing here is we're going half times B times C. So times sine 85. Sine 85, basically what that's going to do in effect, why are you doing sine 85? Sine equals opposite over hypotenuse. Is what we're trying to do is actually get it to give us the direct height of it being perpendicular to this. So I want to know the actual height of this triangle, right? I want this to actually be a right angle. Now, if this is 85 degrees here, then I know that this angle here would be 85 degrees, right? That would be 85 because they're corresponding angles. So I really want to know what this height is. Now, if I know that's 85 and this is 12, I've drawn this the wrong way, actually, because that's my adjacent. I've done that right? Yes. Then we can figure out the height of it. What we're trying to do is really just figure out the height. This sign will correct for the height. So you're going to go really half times 16 times 12 times the included angle, sine the included angle, and that will get you your answer to that. And that's where we're really trying to go with that one. Yeah. It's not too bad, that one. Hopefully, you will get that. Yeah, that's why, because I did have it right. Yeah, so this would be a right angle here. This would be 85 degrees. So let me just pull that out. I'll show you why it works if you want to know. So what you're really trying to do is you're actually trying to find out what this length here is, right? But you've got this. This is now 85 degrees. And we know that this is 12. This is where I did do it wrong, I think. Yep, so that's my hypotenuse, and that should be my opposite, which isn't quite working out right. Let's move on. I'm going to move on. The formula. Don't know why it's not working. This will be the formula for it. I'm drawing it from the wrong end. That's why. And I'll get through it. This one as well, Heron's formula. I'll just copy this formula down too with some examples. So really, it's just about getting these examples in here, which is what we want to be doing. With Heron's formula, the first thing we need to do is find out S. So Heron's formula is when we want to calculate, let's look at what we're going to calculate. We're going to calculate the area on this. So this is to find the area, okay? So sometimes you're given just 3 lengths. If you're given 3 lengths, the first thing you need to do is find the value of S. The value of S is this length plus this length plus this length divided by 2. 8 plus 7 plus 5 divided by 2 equals 10. Then what you do is you're going to have 10 times by the value of S minus this length, 10, or this length, 10 minus 8, times by 10 minus 7, times by 10 minus 5. So once you find out the value of S, add these 3, divide by 2, then it's, in this case, 10 times 10 minus 7 times 10 minus 5 times 10 minus 8. And then it's the square root of all of that. So that's all we're putting the numbers in there. So you're going to be 10 times 2 times 3 times 5, and then you get the answer. If this is a show that question, this is what you need to do. If this was not a show that question, I wouldn't even do any of these. Again, I would just be coming into my CAS, drawing it in here, clicking on this one as 7, this one here as 5, lock it in, and this one as 8, lock it in, and then click on all 3 corners, and you get all 3 sides, and you get the answer of 17.3, which is a lot easier to do than these formulas. You still need to know how to use these. If you don't, use the other one. That's pretty much area of a triangle, and that's all I'm going to go through. So to find the area of these first ones, this one, 2 lengths included angle, you're going to use this formula, half times 12 times 14 times sine 38. This one's Heron's, so you're going to go 6 plus 5 plus 7 divided by 2. So what you'd need to do there, and you need to use, please, the formulas. Make sure you do know how to use them. So I'm going to quickly go through this one for you. Keyboard, now I'll go through menu if you have to do it in main. So this one would be 7 plus 6 plus 5. Don't do divided by 2 here, because now you've only divided 5 by 2. And that's where some people can go wrong, because that's saying 6 plus 7 plus 2.5. We want to divide all of that by 2. So either put it all in brackets and then divide it by 2, or what I would probably encourage you guys to do is to use the fraction bar, because then you kind of can't really go wrong. Some people go really, make some simple mistakes with this. So just be careful. That's my value of S. Now my value of S, now I've got it. So then what we're going to do is we're going to do the square root of the value of S, which is 9, times by 9 by minus 7, 9 minus 6, 9 minus 4, 9 minus 5. So it's S times by S minus length times S minus the other length times X minus the other length. Square root of those, the area of that is 4.7 to 1 decimal place. And centimeters squared. Give units. This would be centimeters squared, millimeters squared. Here, you're going to do half base times height because it's a right angle triangle. That's pretty much it. Any questions on this subchapter? Make sure you got those formulas down. You need those formulas. Have some examples, so then you know what you're doing. Okay, was that it? That was it. There are application of those as well, so please make sure you have a crack at those, because some of them do get a bit tricky. You can make a triangle. We've already done similar figures, so we're going to skip that subchapter. Surface area and volume is what we want to do. Surface area. Really, in here, the main things is you need to know how to calculate the surface area of a cylinder. Well, if you think about what it is it's two circles on the top, right? And if you slit this down the middle on the outside, so you got the two circles, that would, and you unraveled it, that would turn into a rectangle. Now the length of this cylinder is going to be the perimeter of the circle. Hence, it's 2 pi r long. That's 2 pi r long because that's the perimeter of the circle. To find the area, well, it would turn into a rectangle. It would be 2 pi r by h. So what you've got to understand is that this 2 pi r squared is the area of the two circles, plus the area of this, which would be pi r squared, 2 pi r h, 2 pi r, which is the area of the curved side. Sometimes you'll get questions where find the total surface area of this outside of the shape where it doesn't have a lid. So it would just literally then be pi r squared plus 2 pi r h. It might just say it doesn't have a top or a bottom. Find the total outside surface area. That's just going to be 2 pi r h because you're just calculating this. You need to understand how this is broken down because in further maths, especially 3-4, you've got to recognize that this, and what I would actually do personally, how I write this slightly different. I'll just copy this picture to show you guys how I write it. I mean, there's nothing wrong with this way, but what I like to do is I more like to do it like this when I'm doing my notes. So this is where I mean with you guys scribbling things down. This is what I'd like you to be scribbling down at the moment. So I'm going to go through this pretty quickly. Personally, how I like to write my formulas for this is oops, what I do there, did something. This area here is pi r squared. The area here, 2 pi r h. The area here, and I'll be writing like this is under my area notes, right? Area. This is going to be pi r squared. So you're going to add these all together. So therefore it's pi r squared plus pi r squared plus 2 pi r h, which gives you 2 pi r squared plus 2 pi r h. I like this for students who don't get where each of these sections come from. If you get it, well, then that's okay. So you just got to be careful if, like when you're doing cylinders, does it have a top? Does it have a bottom? As long as you know what each of these parts are calculating the areas of, they'll be fine. If you struggle, I would recommend something like that. You'll be fine. R standing for the radius as well. That one's probably the most common one I see broken down in different pieces. Total surface area of a cube. Any questions on that one? Otherwise, I will move on. Surface area of a cube. So what I would do, surface area for a cube, is I would then be having you guys copying all these formulas down. You don't get them all, but if you've got them all, you'll be right. So literally, it's length times length would give you 1 area, right? But there's 6 sides to a cube. So that's why it's 6 times L squared. Here, if you go length times height, you've got 2 of those. You've got the front face and you've got the back face where you can't see. It's kind of like there. Then you've got height by width, which would be like this face on it. And you've also got this face here. So you've got 2 of those. Then you've got 2 lengths of length by width, which would be the top and the bottom. So really your width by height would be your sides. Your length and height would be your front and your back face. The width by length would be your top and your bottom. So you can really add up multiplication of that. What you're doing is you're going length times width. That would give you 1 of those. Then you've gone plus this area, plus 1 of my sides. I've doubled it because I've got 2 sides of each. Now, if one side's missing, you need to know how to add all those up. This one here is obviously, I hope, pretty easy, a right triangular prism. If you think about if you want to add up all the surface areas, well, this would be the back face would be height by length. Height by length. The bottom face would be base by length. That would give you your bottom face, base by length. Base times height. Why can we go base times height? Well, if this is a right angle triangular prism, if you went base times height, it would give you a square because it's actually giving this area and that area. and that's why we have that one there. The last one's a bit tricky. You've got to find this slanted edge, and this slanted edge by length would be it. So it's length, because this is a right-angled pyramid, we've used Pythagoras. So the square root of h squared plus b squared, and that's what gives you that length. So that is length by Pythagoras's, this one. Then we have height by base, because that will give you two of those. I mean, you could go half h by base, but then times it by 2, you're going to get the same thing. So hopefully you can understand how that one works. Please yell out if you're not getting it. A cylinder, you will see a bit more represented like this. You can use the distributive law to distribute that out, because we've just taken out a common factor. Here we can see that what's common in both of these is 2 pi r. So you're left with r in this one, and you're left with h in this one. Because if you distribute this, you get 2 pi r squared plus 2 pi r h. Now, if you've done only year 11 further maths, and you've been using this formula only, I would really encourage you to have this in here and understand that where each of your sections come from, because you might just have a top, and you can't do just a top with this. Like you could figure out the whole thing, and then you could minus pi r squared. But that's going to take you an extra bit of step where you can hopefully just figure out where it's coming from. And that's fine if you want to do it that way too. A sphere, to find out the total surface area, we're not doing volume, 4 pi r squared. Please make sure you copy these down carefully. Look at them. You can even print this page out and stick in your book. I don't care. A cone, where S is the slanted height. So S is the slanted height. It's on the edge of the outside, and that's really important with this. Pi r times by r plus S, and please just put your brackets in where you do it, your radius times S. Your square base pyramid, obviously you need base squared, which will give you the bottom. And then when you think about it, this is going to be base times your height, right, of S, where S is the slanted height. Okay, but it's not, this is a slanted height perpendicular to it. Okay, and now we need to be careful with this one, and this is where I don't kind of like where Ed Rollo goes a little bit astray. You will see that when you're taking notes of this one, don't just assume that's always going to get your answer. This is why I said, and this is where people go, oh yeah, surface area is easy, but you've got to stop and slow down a bit. Don't underestimate it, even if you're like really comfortable. If you go base times S, right, that's when we say slanted height, and this is where it gets a bit different. We're talking about it being perpendicular, which would have to be right in the middle, going all the way up. Because if you think about it, that would be following your triangle, right? Base times height, right? Then you would have to halve it because it will give you the area. Why it's 2 of those is because you've got, 4 lots of half base times height. That would give you 2 base times height, because, obviously 2 of them would, base times height would just give you the area of 2 faces. If this S is on the corner, let's just call it another layer. Let's call the S the edge. If the length is on the edge, and this is where some people go wrong, they'll just go and just say that was 8. That would be incorrect using this, because this is 8, right? And let's just say we knew our base was 10. This would be 10. So what you've got to do is you've actually now got to find your height, and your slanted height is perpendicular, right? This is perpendicular, which it doesn't say, to your base. Then you'd know that this is 5. Then I can use Pythagoras' theorem, right, to figure out what the other length is. 5, 8, this is it. So now I can use Pythag to figure out what my actual height is. So be careful. Sometimes you get questions that say it's along the edge. The slanted edge height is slightly different, okay? So that will be different again compared to actually S is the slant height. So again, it needs to be perpendicular. If it's not perpendicular and you're given like an angle in here, you could be given an angle in here, right? And then, you're given this length is 10 and that length is 8, and just say you're told that this is 60 degrees. Well, now you could go back to your previous subchapter and use the area of this triangle, right? Which is half times base times, yes, this height times by sine 60, for example. Okay, so that also could come into play. Now, I've never seen that, but it wouldn't surprise me if they do something like that. Hopefully that makes a bit of sense. Just clarifying what that S represents. Similarly with your cone, it doesn't matter with the cone here, because if you take the slanted height anywhere around the cone, it's going to be exactly the same length as long as it goes to the outside, right? So that is the slanted height there. This one, a bit different because as you move further out, the slanted height is going to get further and further. So the slanted height is perpendicular to the base and it goes to the top of the pyramid. Cool. Good luck with that one. Hopefully you guys will be all right. There's some good challenging questions in there. Last one, volume. Let's move on to volume. Again, I would make my volume notes and my surface area notes probably separate, but I have some people join them and that is fine. Volume, you just need, what you need to understand is this concept here. That is actually in the VCAR point. It's a skill. Some people don't get this. If you think of what volume is just how we calculate volume. Well, if I've got, say, for example, a rectangle shape, and say that surface area is 50 centimeters squared. If I go a centimeter up, that's going to give me 50 centimeters cubed because I can fit 50 centimeters cubed in there, right? If I go 2 centimeters up, that's going to give me a total of 100 centimeters cubed because we're actually going up now. Now I'm going to have 2 layers, of going up with 50 centimeters cubes. If I go 3 up, it's going to give me 150 centimeters cubed. Now, a lot of you know formulas, but some people don't get the concept of this. So please bear with me. Don't underestimate this. So what you've got to understand is that, well, how do we calculate area? Well, really what we're doing is we're using our cross section. And what a cross section is a cross section can be defined as a section where you take a cross out of it. And as long as I can push this rectangular shape up and down and it doesn't change its dimensions, I can then take its area and multiply by far up and down I go, or in and out. So with a rectangular prism, you can actually find out area many different ways. That's not really a good rectangle, but let's just presume that is going that way. So I could find out this area and then multiply it by the length going this way, right? Because that would then, by the length going that way, because then that would give me this area multiplied by the length. I could just keep on stacking centimeter cubes on there. Alternatively, I could take the front face and multiply it by that way, because if I push that face all the way through that direction, it's still going to be the same shape. Or I could take the top or the bottom and push it down and I'm still going to get it. Hence, it's like height times width times length. Like you could go height times width times length, or I could go width times length. Stylus is gone. So when it comes to like a Toblerone box, because everyone loves chocolate, right? You can't, there's only one way you can find out the volume of this. Now you need to figure out the cross section of the triangle, this one, because if I push that triangle all the way through here, it won't change its shape. So why the formula for this is half times base times height times length is because this is going to give you the area of the triangle times the length would then start making it 3D. It's about, oh, how many centimeter cubes can I put in there, or meters cubes, right? You just keep on stacking them on top of themselves. Now I can't take this face on the triangle and push it down, because if I took, I'm just going to draw a new one. If I took a side face, I'm nearly out of time. That's okay. If I took this side face here and pushed it through, you'd note that the first shape would be rectangular, but then it's going to get narrower as we go through, right? And then it's going to get like really skinny, at the end. So it changes its shape. So I can't take that and go through there. So a good typical question is like a garden hose. You might see, it's 20 meters long and you're given the radius and you say, what's its volume? Well, if you think about a garden hose, it's cylindrical the whole way through. So you can just figure out the area of the circle and then multiply by how long it is, and it will tell me the volume. One other thing you need to understand is that 1,000 centimeters cubed equals 1 litre. That is really important because sometimes you're asked to convert into litres. So it's 1,000 centimeters cubed is a litre because 1 centimeter cubed is 1 milliliter. So that cross section is really important. So like what I'll do is like a sponge, if I give you a sponge like this, a typical car sponge, and I say, hey, this is 50 centimeters squared and it goes 10 centimeters deep. what's the volume of this sponge, right? And assuming that that is exactly the same shape. If this was 10 centimeters high, well, the volume of this would be 50 times 10, which is 500 centimeters cubed, which would also be 0.5 liters, depending on what you want to answer as. Now, that would be fine if it just said volume, but if it asked it for in liters, you'd have to convert it. So really, that's a really important concept. Another one is if you so let's just have a quick look at some of the others. So again, we've got length cubed because it's length by length by length, length by width by height. This is the area of the triangle, half base times length by height by length because it's a cross section. A cylinder would be, well, the only cross section would be your area. So it's pi r squared to get your area of that times by your height. A sphere, 4 on 3 times pi r cubed. If it's a pyramid, if there's any shape that's a pyramid, so a pyramid means all the edges go to one point. What you'll notice with a pyramid, and some people haven't realized, but if it's a pyramid, if it's a square base pyramid, well, all I do is I treat this as a, so that's base, and I just go base times height. Now that would give me a rectangle, right? Or you could say a square base rectangle if I went base times height. Now, the thing with a pyramid is that a pyramid takes up a third of its original shape. So if all the points go to the other point in the middle, so we're talking about these points go to, I should draw this edge down there to the middle. This point goes to here, this point goes to here, and this back edge also goes to here. If it's a pyramid, the volume of this equals a third of the original one. So if you've got a cone, for example, a cone actually, you'll fit 3 amount of the volumes of a cone into its original cylinder. So you'll notice when you actually come to pyramids, like this is the same thing as a cylinder, but multiplied by a third. This is the same thing as a rectangle, but multiplied by a rectangular prism, but multiplied by a third. So here it's pi r cubed, pi r squared times height, which is this. But it's a third of it because only a third of the volume would be taken up in that. Similarly, when you're looking at an area of this one, well, because this is a square based, it's going to be 6 by 6 by 5, right? Area of the cross section by the height, but then it's a third, and it's a third because 3 of those will get in there. So it's a third, volume of a pyramid is a third by the area of the base by the perpendicular height. So you take the area of the base, multiply by its height, and then you multiply it by a third because it takes up only a third of it. So same thing here, area of the base, multiplied by the height, pi r squared by height by a third. And that is it. If you need to convert between units, that's really important too. Converting between units, if you're going between cubed units, so millimeters to centimeters, you normally divide by 10. Centimeters to meters, you divide by 100. You're just going to do it to the power of 3. If it's area, millimeters cubed to centimeters cubed, you're going to divide by 10 squared, divide by 100 squared. If it's just units length, millimeters, centimeters, just divide by 10. So depending on what unit it is, use the same units as you'd normally convert, but you just put it to the power of that and you'll get there. 1 centimeter cubed is 1 millimeter. And that is it. Sorry to go a little bit over time, but we got it in there, which is great. So